The year is 1892. A mysterious disease is sweeping across prized tobacco crops. Dmitry Ivanovsky noticed that infected tobacco that had been put through a bacteria filter somehow still remains infectious to healthy tobacco. Martinus Beijerinck gave it a name, venomous substance. They had made a discovery that would change pathology forever. They had discovered a virus. Now, it's 2018, and you probably recognize a virus before, whether it's like this, a cold, or a bit more close up and personal, like this, a bacteriophage. Viruses come in many different shapes and sizes, and they've been infecting living things all across the world, just minding their own business since the dawn of time. Strong evidence has shown that bacteria and viruses evolved from the same ancient cellular life form, but whereas bacteria evolved to become more and more complex, viruses evolved to become simpler and simpler. But what exactly is a virus? A virus is an infective agent that contains genetic material within a surrounding protein envelope. A virus must be supported by a specific host and cannot survive outside of that host. Most viruses prefer the minimalist life, cutting out all but the most essential genetic info it needs to infect a host cell and reproduce. Okay, so how does a virus infect something? Well, first it comes in contact with its host cells. A virus may disguise itself as a bit of food or useful nutrient, tricking the host cell into enveloping it. Others may attach to the receptors of the membrane of the cell and simply inject its genetic material into the cell. In the Leydig cycle, after the attachment of the bacteriophage and penetration of the membrane of the host, the cell is officially infected. Its metabolism is shifted and its DNA is degraded. The cell's replication and translation mechanisms are hijacked. Now those once healthy cells are virus factories, pumping out viral proteins and genetic material. After only 25 minutes, around 200 new bacteriophages have been created within the infected cell. The number continues to climb until eventually bursting, killing the cell and releasing the mature phages to continue the cycle. Viruses are not animals, plants, fungus, bacteria, and they're not classified as eukaryotes or prokaryotes. In fact, we're not even sure if they're alive. The currently accepted list of things that a virus alive must have, viruses do not quite fill out. However, it is theorized that a virus could possibly become alive if it keeps doing what it does best, replicate segments of its host's genetic material and mutate to do things we couldn't even imagine. In 2016, it was discovered that one type of virus took genetic material from black widows to create its own venom. Viruses can mutate with extreme quickness and efficiency. One type of vaccine for a strain of virus may quickly become obsolete due to the virus's adaptable genetic material replacing nature. That's what makes them so dangerous. But leave it to science to find a way to use something that poses a huge threat and turn it into gold. There is great potential to use viruses' ability to deliver genetic material to make massive breakthroughs in genetic engineering. A virus can even transfer genetic information between different species of hosts. In some cases, this may have led to serve as a means of evolutionary change. Nearly 10% of the human genome is DNA from viruses. Some evidence implies that viruses could have given us the genetic information for the manufacturing of placenta. There is great potential in using viruses to edit bad DNA, such as the section responsible for genetic disease, and rewrite it into useful sections, like having better eyesight or stronger teeth. Theoretically, we could have many genetic advantages, and in turn change the evolution of humans forever. But we're still studying how viruses can be used in this way, and it isn't all clear how much of an impact this has in the evolutionary mechanism. Today, and every day, we're making amazing new discoveries in the small, simple, adaptable virus. Will the virus's drive to reproduce and genetic adaptability inevitably end all life on Earth as we know it? Or will it be an evolutionary tool, a life-saving means of editing genetic ailments and a great advantages for the human race and onward? I guess only time and science will tell.